Okay, this is the Unit 8 review, and you will need a calculator and a formula chart while you're doing this review. Okay, the first one says, can segments with the lengths of 4.3, 2.1, and 5.2 form a right triangle? Hint, use the Pythagorean theorem. So we are going to take the two smaller lengths, which would be our A and our B, and our largest is going to be our C. So we would set that up as 4.3 squared plus 2.1 squared. And we're going to see if that is equal to 5.2 squared. And you could just literally put that in your calculator at the same time. So you would do 4.3 squared plus 2.1 squared, enter, and that's 22.9 for this side. And on the other side, we have 5.2 squared, and that is 27.04. So that does not make a right triangle because it's not equal. And actually, it would make since 22.9 is less than 27.09, it would actually make an obtuse triangle. And that's what we're going to do in the next problem, which is apply that principle. So we have a 6 squared. These could be our A and our B. So 6 squared plus 7 squared. And we're going to see what symbol we need to put in there. So again, we go to our calculator, 6 squared plus 7 squared, and that's going to equal 85. And then 8 squared is just 164. So since 85 is less than 164, it is going to be an obtuse. If you ever ended up with something like 25 on one side and, I don't know, like 15 on the other, and this ended up to be greater than, then that would form a acute triangle. Okay, number 3, it says solve for the variable, remember to simplify any radicals, don't use decimals, show all your work. Okay, so on this one, you would need to do the bunny, where you would, to solve for x, you would run all this way right here, which is going to be 5 plus 2, which equals 7. Then you're going to run up here. So we're going to set the ratio. So we would start out with 7 over x equals, and then come back down, go x, and go down, that would be 2. Cross multiply, so we have x times x, which is x squared. And then we have 7 times 2, which is equal to 14. And then we get the square root. The x by itself, we take the square root. So this just becomes x. And the square root of 14, it's not a perfect square. And we can't take out anything out of it because it just breaks down to 7 and 2, and that's not going to help us. So you would just leave your answer as the square root of 14. So this is the equation you would use, and this is your answer. Okay, for this one, looks like we're going to use heartbeat since we have something in the middle. So we would go 20 over x equals x over 5. 20 over x equals x over 5. Cross multiply, we have x times x is x squared. And then 20 times 5 is going to equal 100. Then we take the square root of both sides, so x would equal 10. That's your answer, and here's your equation. Now this is where you would use your formula chart for the 45, 45, 90, and the 30, 60, 90. So the first question is a 45, 45, so we know it's gonna follow this pattern right here. So they've given us our leg of 9, so we know our other leg is 9. And to get from our leg to our hypotenuse, we just have to multiply by the square root of 2. So this would just be 9 root 2. For number 6, it's a 30, 60, 90. So we would follow this pattern. And they have given us the hypotenuse. So to go from the hypotenuse to our short leg across from the 30, we just divide by 2. So divide by 2, and that gives us 7. So x equals 7. Number 7 says a support wire for a telephone pole will be dropped from the top of the pole to the ground at an angle of 45 degrees. How long must the wire be? 9 meters would be nearest 10. Okay, so we know that this is a 45, 45. We have one side, so we know the other side is 12. And then we just know that this, to go from our leg to our hypotenuse, it's going to be 12 root 2 times the square root of 2. So we're just going to put that in our calculator. Remember, put that in your calculator. Just do 12 and then the second button, and then that didn't work. 12 and then the second button, and then get that square root and put in 2. So your answer is 16.97, so B. Number 8 says, what is the value of x in the triangle below? So this is a 30, 60, 90 triangle, and they've actually given us the middle side. So the middle side, to go backwards to our x across from our 30, we have to just divide that by the square root of 3. So when we divide 4 root 3 by the square root of 3, our square roots cross out, so we're really just left with 4. So it's going to be D. Number 9 says, what's the perimeter of the square of the diagonal of 10 root 2? Okay, so we know that this is going to be a square, always has a 45, 45 in it. So our pattern says if we're going to go from our hypotenuse back to our leg, we divide by the square root of 2. So 10 root 2 divided by the square root of 2 is just going to be 10. So we get to cross out those square roots. So each side is 10. So the perimeter is just adding all the way around. So 10 plus 10 plus 10 plus 10 is going to be 40. For number 10, it says, Mrs. Smith asked her students to look at the drawing shown to determine the length of D. Which of the following student responses best represent the length of D? So the length of D is right here. And we know that one part of that is going to be 3. The length is 3. And the other part is going to be 6. And look at this little triangle right here. Transfer that 6 over. And so we know we can do the Pythagorean theorem because it's going to be a right angle. So we could do a squared plus b squared equals c squared. So then we just fill in. So this would be, we can call this one our A and this one our B. So we would do 3 squared plus 6 squared equals c squared. 3 squared is 9 plus 6 squared, 36 equals c squared. 9 plus 36 is 45. So 45 equals c squared. And then we just take our square root. So we can break down 45. This side just becomes c. 45 breaks down to 9 times 5. 9 is perfect, so we circle that. It comes out of our square root. And we have 3. The square root of 9 is 3. And then we have 5 left behind. Oh, we didn't have to do all that. So really you could just put that in your calculator, the square root of 45 from the very beginning. And that was 6.7. So just be aware of what your answers are in. If they were in square roots, you would need to do what we did over here. Okay, next one says find the length of the altitude, which is right here. And remember, this is a equilateral triangle, so it's already marked as a 30, 60, 90 triangle. They've given us one side, which is our hypotenuse. So the side across from our 30 is going to be our smallest side, or just our x. So we just divide that 6 by 2 to get to this side. And then to go from our small side to our middle side, we multiply that 3 by the square root of 3. So it should be 3 root 3. Number 12 says determine the length of the diagonal of the rectangle with width 3 and length 4. And this is a very, very popular Pythagorean triple, 3, 4, 5. But if you don't remember that, then you would do the Pythagorean theorem. And this side right here is our C. And it doesn't matter which one you call A or B. C would be 3 squared plus 4 squared equals C squared. 3 squared is 9, plus 4 squared is 16 equals C squared. 9 plus 16 is 25. And then just take your square root. Square root of 25 is 5 equals C. Okay, the next one, we're going to talk about those trig ratios that we learned, where we use SOHCAHTOA. So make sure that your calculator is in degree mode. To do that, you want to hit the mode button and cursor down to where it says radian, and then cursor across the degree and press enter. And second click to get back to your regular screen. Okay, so now they want us to tell them the sign of A. So we want to circle A and say which sides we have. So we have across from the angle A is our opposite side. The side that's right next to it is our adjacent side. And then of course our hypotenuse is always across from the right angle, so this will be our H. To get our sign, we need to use the sign ratio is going to be opposite, which is our 3, over hypotenuse, which is 12, and you want to reduce that. If you don't know how to reduce it in your head, just hit 3 divided by 12, and then math iterator. So it reduces to 1/4. Okay, then we want to erase that. We're going to erase, no, we can keep everything, because we're still talking about A and 14, so we can use what we have on our figure. So this time we're looking for the tangent of A, so we're going to use this ratio right here. So the tan would be opposite, so that would be 3 over adjacent, which is 6. 3 over 6, which reduces to 1/2. Okay, now for B, for angle B, we're going to have to redo. The hypotenuse will stay as the hypotenuse, but from B, the sides change. So when we're looking from B, the side right next door is going to be the adjacent side, and the one across the way is going to be our opposite side. So now they're asking us for the cosine of B, so that's going to be pi. And we need to use adjacent, so we would use 3 over hypotenuse, which is 12, and reduce that. Looks like we already reduced it before, so it's 1/4. And then we need the tan of B, so that would be, the tan of B would be TOA, so opposite over adjacent, so 6 over 3, and reduce. So that 6 divided by 3 equals 3. Okay, now we're gonna solve some more problems using SOHCAHTOA. So we need to set this up. So from this angle, let's label our sides. So across the way is opposite. Right next door is adjacent. So we would use, since we only have O and A, we would use the tangent. Okay, so we would set up our equation as the tan of 37 of our angle is equal to opposite x over adjacent 25. And I like to just set them all up as proportions and cross multiply. So just put this side over 1 and cross multiply. So x would equal the tan of 37, the tan of 37 times 25. And just put that in your calculator. So we have the tan of 37, and just make sure you close your parentheses right here, and then multiply by 25, enter. So your angle is, it says round angles and sides to the nearest integer. So we're going to look for whole numbers. So if I round that to a whole number, that's going to be 19. Okay, for number 18, we have an angle, and let's label the sides. So we have right next door is our adjacent, and then across from our across from our right angle is our hypotenuse. So we have to use our cosine, because we have adjacent and hypotenuse. So we're going to say the cosine of 43 is equal to 16 over x. No, sorry. That's supposed to be adjacent over hypotenuse, so x over 16. So again, we still cross multiply, so we were left with, so x equals the cosine of 43 times 16. So calculator, cosine 43, close our parentheses, and then multiply times 16. And I got 11.7, so that rounds up to 12. So this side is 12. Okay, finally, on number 19, we have, we're given just an x, so we don't know what the angle is, so we're solving for this angle right here. And we have a side, the side that we have is, the next door is adjacent, and across from the right is going to be our hypotenuse. So we have to use again, C-A-H. So cosine, the cosine. Now the only thing you have to remember on this one is when you're finding an angle, you have to hit the cosine to the -1. Okay, so cosine to the -1, and I'll show you that button in a minute, and then just simply put your ratio in there. So adjacent, so 8 over 17. So come over here to your calculator and hit your second button and the cosine button. And then it gives you a bracket, just put in 8 divided by 17, close your parentheses, enter. And so that angle ended up to be 61.9, so I'm going to round that to 62 degrees. And that makes sense. If you got something like 150 or some negative number, then go back and check if you're not in degree mode, switch it to degree mode, or you just typed something in wrong. Okay, number 20, the equation, we have this angle right here, and our sides are, this is adjacent, and hypotenuse. So we're trying to find the hypotenuse. Again, we're going to use cos because we have adjacent and hypotenuse. So our equation would be the cosine of 42 would equal 10 over x. Now this gets a little trickier because the x is in the bottom of our equation, but it's not a problem. So we would still cross multiply. So we would have the cosine of x, no, cosine of 42 times x, and equals 10 times 1, 10. And then all you have to do is get rid of the cosine 42, so x will be by itself, so divide by the cosine of 42. This crosses out on that side, so x would equal, and then you put that in your calculator, 10 divided by the cosine of 42. Close your parentheses and hit enter. So that would round to just 13. So this hypotenuse is 13, which makes sense because the hypotenuse should be bigger than our other side of 10. Okay, the next one, it says you're at a drive-in movie and you're 25 feet from the screen, and your eye is on the horizontal line with the bottom of the screen, and the angle of elevation to the top is 58 degrees. How tall is the screen? So we want to find out how tall that screen is. So in relation to our angle that we have here, we have our opposite side right here, and we also have our adjacent side. So we have to use TOA, T-O-A, because we have these two sides. Okay, so the tan of 58 degrees is equal to opposite x over 25. Then we want to set it up like a proportion and cross multiply. So we have x times 1, and then the tan of 58 times 25. Then we can put that, as soon as you get x by itself, you can put it in the calculator. So we have tan 58, close our parentheses, times 25. And that just equals 40. So this is your equation, and here's your answer. For number 22, it looks like we have a tree that has a shadow of 6.3 on the ground, and they want to know what the height of the tree is, so this would be our x. So in relationship to our angle right here, we have our adjacent side, and we have our opposite side. So we're going to use TOA again. So the tan 50 would equal x over 6.3. Cross multiply, x times 1 is x. And then we just have our tan 50 times 6.3. Calculator, so tan 50 close our parentheses times 6.3, and so our tree is actually 7.5 meters tall. Okay, then how many feet tall is the street lamp? So we've got our angle right here, 40 degrees, so we have our adjacent side to that and our opposite side. So again, we're going to use TOA. So the tan 40 degrees equals h over 15. You can cross multiply that out, so that would be h equals the tan of 40 times 15. So the tan of 40, close your parentheses, times 15. So your okay, I'm getting 12.58. So I don't know if I misread this angle. I think it says 40. It definitely says 40. But let me just try that one more time. I think that's right though. So the tan of 40, close my parentheses, times 15. And that is right. So our answer choices here are not correct. So we'll just go with the, let's just round that to 12.6. And that's it. Okay.